Okay, welcome back to the second video that I'm going to do on completing a square. We're going to do some slightly harder examples in this one. So our first example, or if you're following on from the last video, which is example 3, what we're going to do is we're going to take this equation of a circle and we're going to put it into the point center form. So we're basically going to take this equation, we're going to rearrange it into the form of x minus h all squared plus y minus k all squared is equal to r squared. So we're going to take it from this and we're going to make it look like that, just so it's a little bit easier for us to translate and move around on our x and y axis. Okay, so let's get stuck into it. The first step that I told you to do whenever you're trying to complete the square is to group the x's with the x's and the y's with the y's. Well, that's pretty convenient for us because that's already been done for us. We have our x squared with our minus 6x and our y squared plus our 4y. The second step that I told you to do was to move any constants that you have on the left-hand side over to the right-hand side. Well, we're also pretty lucky in this question because that's also been done for us, okay? So, let's take our equation, x squared minus 6x plus y squared plus 4y equal to 36. And we're going to complete the square twice on this. So at the end of last video on my example, I showed you a bit of a quicker way to complete the square, right? So we're going to complete the square on the x, and we're also going to complete the square on the y. So let's start with the x here. So if we're completing the square on this term, we're going to end up with an x inside of a bracket with something else all squared. Now all of this other stuff in this equation stays the same. So plus y squared plus 4y is equal to 36. That doesn't disappear. Okay, now what goes into this bracket is the same sign, okay, so it is a negative of the x term, okay, so the same sign as the x term and half of the coefficient of the x term. Well, half of 6 is 3. Now, remember I told you, because we've done that, we need to add on whatever this number is in here, this 3, to the other side, the right-hand side squared. So we're going to add on, I might do that in red so you can see what we're doing, we're going to add on 3 squared. Okay, alright, so let's just tidy this up a little bit. Okay, so x minus 3 all squared plus y squared plus 4y is equal to 36 plus 3 squared is equal to 36 plus 9, which is equal to 45. Okay, now what we're going to do is we're going to complete the square on the y's. Okay, so what we're going to end up with is x minus 3 all squared. That doesn't change, that stays the same. What's going to change is we're going to end up with y inside of a bracket with something going on in here all squared, which is equal to 45. So nothing else has changed yet. So what goes inside of this bracket is the same sign as the coefficient of the y, so it's a plus, and half of the coefficient of the y term. So same sign, but half the number. Okay, so half of 4 is 2, and remember, because we put this in here, we also need to add on 2 squared. Now please don't forget to make sure that you add it on squared to the other side. That is a heed my word moment. I quite often make that mistake when I'm doing it. Okay, so make sure that you add it on squared. So let's tidy up a little bit. Okay, x minus 3 all squared, the left hand side doesn't really change. We've done all the tidying up and we've completed the square on the left hand side, which is what we wanted to, which is equal to 45 plus 2 squared, which is 45, plus 4, which is equal to 49. Now, this is really easy to identify the center, okay, and the radius of this particular circle, because we've taken our original equation here and put it into a form that looks like our point center form that we wanted. Okay, so remember the center of our circle, okay, is equal to the opposite of these brackets. So the opposite of negative 3 for the x is positive 3, and the opposite of positive 2 for the y is minus 2. So the center is at 3 and minus 2. Now the radius is equal to the square root, right? Remember, this is r squared up here. This 49 is r squared. It's equal to the square root of 49, which means that our radius is equal to 7. So that is the distance from the center to the outside of our circle. So our center is 3 and minus 2, and our radius is equal to 7. Now let's say that we wanted to go along the path of finding the x and y axis, and I'm going to include this example because I wanted to show you something that's a little bit harder, okay, and where you might have to simplify a little bit more of the surds and all of that sort of stuff, okay. So this is not going to be a breeze in the park, okay, but we can do it. We have all the skills necessary to do it. We've used them before. So say I want to find my y-intercept. Okay, remember to find our y-intercept we let x equal 0. Okay, so we're just going to use this equation down here, this one here. Okay, so you can see everything that I'm going to do. So if I let x equal 0, I'm going to end up with minus 3 all squared, replacing this with a 0. So 0 minus 3 is just minus 3 all squared, plus y plus 2 all squared, which is equal to 49. Okay, so now we end up with minus 3 squared is 9, plus y plus 2 all squared is equal to 49. Now in my last video I made a mistake with negatives, try and avoid that, okay, but even I make mistakes. Okay, so we're going to minus 9 from both sides. So we now have y plus 2 all squared is equal to 49, minus 9 is just 40. Now, here's where it becomes a little bit tricky, okay? We need to unlock the y plus 2, okay, which means we need to take the square root of both sides. But when we take the square root of 40, okay, it's not a square number, it doesn't simplify down to a nice whole number. We can, however, simplify this third. Okay, so we've taken the square root of both sides. We now have y plus 2. Now remember, we've taken the square root. Okay, so we must add a plus or a minus the square root of 40. Now remember, to simplify the square root of 40, we're looking for square numbers that can go into 40. Okay, to break it apart and multiply. So I'm just going to go through this quickly. The square root of 40 is equal to root 4 times root 10. Okay, right, and root 4 is equal to 2. And it's just left as 2 root 10. So now we have y plus 2 is equal to plus or minus 2 root 10. Okay, so let me just move this up a little bit further so you can see what we're doing. Now we're going to minus 2 from both sides, again being careful with negatives. Okay, so minusing 2 we end up with minus 2 plus or minus 2 root 10 for the y-intercepts. Okay, now if you want to graph this, you're not going to be able to do this easily. These are exact values, so you want to get a bit of an idea, a sense of scale, to put it onto your graph paper, which means you're just going to enter this into a calculator. So minus 2 root 10 and minus 2 plus 2 root 10, which gives you the y-intercepts as being roughly, just as a decimal, right, not as our exact value, as minus 8.3 and 4.321 dp. Okay, alright, so now let's find our x-intercepts. We're going to do a very similar method, okay, like we've done before. Find our x-intercepts, we let y equal 0. So that means in this equation up here, we're going to replace every y that we see with a 0, so we end up with x minus 3 all squared, plus, well, y plus 2, if it's a 0, it just becomes 2 squared, is equal to 49, okay? So 2 squared is equal to 4, so now we have x minus 3 all squared plus 4 is equal to 49. We're going to minus 4 from both sides. Okay, x minus 3 all squared is equal to 49 minus 4 is 45. And now, just like last time, we want to unlock what's inside those brackets. We've got to get rid of the square, so the opposite of the square is the square root. So we're going to square root both sides. Okay, so when we take the square root of 45, we need to simplify this down again. Again, we're looking for square numbers that are going to go into 45 to try and break it down a little bit. Okay, and the first number that comes to mind for me would be 9 times 5. So we now have the square root of 9 times the square root of 5, and the square root of 9 is 3. So we now just have the square root of 5, and we can't break that down any further. I might just put some equal signs there so we can see what we've done. So x minus 3, we've taken the square root, and because we've taken the square root, we're going to plus or minus, we cannot forget that. And the square root of 45 we know is equal to 3 root 5. So, continuing on, we'll simplify this a little bit. We're going to add 3 to both sides because it's a minus, so we do the opposite. So 3 plus or minus 3 square root 5. Okay, now those are our x-intercepts. Just like over here we have our y-intercepts. But to approximate them, okay, because remember we're trying to, there needs to be a squiggly line, we're trying to get a bit of a sense of the scale for our grid paper, and it's not easy to do when we have surds involved. Okay, if we approximate them to one decimal place, we end up with minus 3.7 and 9.7, again to one decimal place. Okay, so now let's have a bit of a play with graphing this. Okay, so to graph this, okay, remember we found the center to be 3 and minus 2. Okay, so 3 and minus 2. Alright, so across 3 and down 2. Okay, so just keep that in mind. We're not going to have nice and neat and even numbers like we did before. We did end up with those surds. So I've just written down the decimal approximations. Okay, so we have our y-intercepts as being at minus 8.3 and 4.3. Okay, so minus 8.3. Remember, these are all rough for me. I don't have graph paper. I don't have that luxury at the moment. So minus 8.3 going down. Okay, and then at 4.3. So we're going to go up 4.3, roughly. Okay, remember, I'm hoping you have graph paper for this, so that'll help you out a little bit when you're graphing this. Then for the x-intercepts, we're going to go for negative 3.7. So we go across to negative 3.7. Okay, now a circle might go through that. That's a bit of a bad placement of the numbers. Right, and across to 9.7, so we go positive, so across here to 9.7. Okay, and now that's all that's left to do is to actually graph our circle through each of these intersecting points. Okay, so we're graphing our circle. Okay, remember it is only a sketch. Alright, that's roughly what it's going to look like. Again, really helps if you have a compass for these types of examples to sort of help you out. So that's our circle of x minus 3 all squared plus y plus 2 all squared equal to 49. Okay, so one more example for you, one that doesn't have any intercepts, just so you can get a little bit of a feel for this. Alright, and we'll finish up on that one. Okay, for our final example here, okay, we're just going to go through the steps. This is going to be a little bit quicker because we've practiced the steps a few times now. So we're just going to complete the square to get this into center radius form, okay, and then we're going to try and graph it. Okay, so first things first, we need to group the x's with the x's and the y's with the y's, and that's already been done for us. We can see that. Our second step is we need to move any constant on the left-hand side, so this plus 33, to the right-hand side of the equation. So we're going to minus 33 from both sides. Okay, so we now have x squared plus 6x. This doesn't change. Plus y squared plus 10y is now equal to minus 33. All right, now the next step, okay, so follow through with me. We're going to complete the square on the x's. Okay, so we're going to end up with an x inside of a bracket, all squared, plus y squared plus 10y. This doesn't change, okay, over here, just remembering that. Now, what needs to go in this bracket is the same sign, but half the number, okay, of the x. So the same sign, which is plus, and half the number, which is 3. So half of 6 is 3. Now, because we've put a 3 into this bracket, we need to remember that we also need to add on 3 squared to the right-hand side, okay? Now, what we're going to do is we're going to simplify this up a little bit, okay? We're just going to tidy up the right-hand side. So we now have x plus 3 all squared plus y squared plus 10y is equal to minus 33 plus 3 squared is 9. So minus 33 plus 9 is actually equal to minus 24. Okay, now we're going to complete the square on the y terms. Okay, so we now have x plus 3 all squared plus, okay, we know we're going to end up with y inside of a bracket and with something all squared is equal to minus 24. What we're going to do is we're going to add on the same sign, so plus, but half the number, which is half of 10, which is 5. Now, because we've done that, we need to add on the same number as this squared on the other side, okay? So same sign, half the number, add that number squared onto the right-hand side, and that is how you complete the square quickly. Okay, so we now have x plus 3 squared plus y plus 5 all squared is equal to, now, minus 24 plus 5 squared. Well, 5 squared is 25, and minus 24 plus 25 is just equal to 1. Okay, so now what we're going to do, all right, it's really easy to do with identifying the center and the radius now because we've gotten into the center radius form. We completed the square twice. So the center, okay, remember it's always going to be the opposite of what's in the bracket. So the opposite of positive 3 is minus 3 and the opposite of positive 5 is minus 5. Okay, and the radius, well, that's equal to the square root of the number on the right hand side. Well, the square root of 1 is just 1. Okay. Alright, so now what we've found is the center and the radius, and that was really, really easy to do. Okay, now I'm going to jump straight into drawing this one. We're going to have a little bit of think about why I'm not going to try and find any X or Y intercepts. So just give me a moment to draw up the X and Y axes. I encourage you to actually pause the video here and think about why we're not going to have any X or Y intercepts. Okay, so we've identified the center, okay, which is at -3 and -5. So I'm going to just go ahead and put that here on our graph. So it's going to be across here at -3, and we're going to go down to -5. Okay, so -5. So this is roughly where our center is going to be. Okay, now I want you to think about it. This circle has a radius of 1, so it does not have the distance to actually make it back to the y-axis. And you can think about this logically, right? It also means that it also is not going to be able to make it back to the x-axis. So it's not going to intercept either of them at all. So when we draw this circle, okay, what we end up with is just a circle of radius 1 with a center at -3, -5. And that's why there's no x or y intercepts in this particular example. Okay, so that's our circle of x plus 3 all squared plus y plus 5 all squared equal to 1. Okay, so I hope this helps in your understanding of graphing circles using completing the square to get it into center point form, okay, center radius form. So just remember, just be careful with negatives, be careful with adding on the squared number to the other side whenever you're completing a square, and just work your way through it step by step. This isn't something that you have to do in all of one big go, because that's likely where you're going to make mistakes. Okay, so I hope this helps, and good luck with it all.